Today, our lesson is about polarization. So, by the end of the topic, today we will find the answers to the following questions. What is polarization? Second, how does polarization happen? What are the different types of polarization? And then in the end, we are going to discuss some of the applications of polarization. So, yesterday, as I asked many of you to bring your glasses with you, those who have them, so you can wear your glasses and check whether you can see some differences in the intensity of light or not. If you feel any intensity differences in the light or in any of the application while seeing on your computer, on your mobile screens, so you can notify your observations, and then we will discuss later on. Move on to polarization. What is polarization basically? Before going into depth of polarization, we must study what is an unpolarized light. The light which you are seeing from sun, from incandescent bulb, or from any other source, which is a white light in our daily routine, that is unpolarized light. Why? Because particles in that light, they are vibrating in multitude directions. What is meant by multitude direction is they are randomly going in all directions. Just like you can see on this side, like I have drawn all the directions which are possible in this case. Like some of the particles, they are vibrating in this direction, some of the particles, they are vibrating in another direction. Their way of transferring energy is the direction of the wave, which is this black line going in this direction. That is the way of transferring energy. So this is an unpolarized light in which particles tend to vibrate in all directions. So the process in which we convert or we transform the unpolarized light into polarized light, that is known as your polarization. And what happens in polarization? That is another question. Like we know about the process, like unpolarized light has been converted into polarized. But what is basically happening in polarization? Polarization is a property or a characteristic of transverse waves. I assume and I know that you all know about transverse waves, those waves in which particles are vibrating perpendicular to the direction of their motion. So transverse waves in which the particles are vibrating perpendicularly. So polarization happens in only transverse waves. Now, what is going on inside polarization? In polarization, light tends to vibrate only in a single plane, which means either it is vibrating, the particles are vibrating vertically or horizontally. They cannot vibrate simultaneously in both directions. If they will be simultaneously vibrating, it means the light is unpolarized. But if the particles tend to vibrate only in a single plane, it means the light is polarized. Now coming towards another question, which I must know, like in your heads is going to be pop out. That is how we can make it polarized. So for polarization or for making a light to be polarized, we use a device or we use a component which is known as polarides. What are polarides? Polarides are devices which have certain or specific structure. You can say they have a specific composition, which is of certain molecules, like molecules in them are going to be aligned in such a way, like they are going to absorb one plane of light basically. For example, if electromagnetic light is directly coming towards a polaride, and in that polaride, the molecules alignment is horizontal. So they are going to absorb horizontal light and they're going to allow or let pass through the vertical light, which means in a polaride in which particles alignment is horizontal, the polaride is considered to be as a vertical polaride, which is basically, you can say, according to the alignment of the molecules, the polaride works oppositely. So let me draw in front of you like how polarides look like. For example, this is a polaride which is said to be as a vertical polaride. So let me draw its thing. So this vertical polaride basically allows the vertical component of the light to pass through. But in this case, the molecules are arranged in horizontal manner. They are going to have a bond in this form. So they are absorbing horizontal portion of the light, allowing the vertical portion to pass through. This is how they are chained up, the molecules. They have long chains and they are absorbing the particles. Similarly, the case goes with horizontal polarized as well. Now, let's do a short activity to make this concept much more clear in our minds. So I'll be dividing you guys in groups of 3. Each group has a pair of polarizing filters. So you guys can observe and look around you with those polarized filters, like how to investigate different sources of light. For example, light is coming through screen of your laptops, through screen of your mobile phones, from a lamp inside a classroom, from sun, from outside the screen. So these all different sources of lights are going to be examined under polarizing filters. So all these 3 students, they are going to examine what these observations are, and then they are going to notify those observations, and then we are going to discuss all those observations in the whole class. Okay. Now, as all the observations are collected, so we are going to move on towards methods of polarization. Polarization have different types. The type which we are going to discuss today is linear polarization. We had elliptical and circular polarization as well. But due to shortage of time, we'll discuss those circular polarization and elliptical polarization in some other day. But for now, we are going to discuss linear polarization. So linear polarization is that type in which the oscillation of particles are going to be only in one direction, either horizontal or vertical, which I previously mentioned as well. So that polarization in which one plane or one direction vibration has been observed is known as your linear polarization. Now, coming towards methods of polarization, how polarization can be achieved in different methods. There are a variety of methods. In total, we can discuss 4, but now we are going to discuss only 2 of them, which are quite interesting phenomena as well. So polarization have different methods. One is by reflection method, which is a very common method you can observe around you as well in daily routine as well. So by reflection, what is happening in that case? Unpolarized light can be polarized with the help of reflection, partially or completely as well. Depends upon how the incident light is falling on that surface. But how reflection is giving you a polarization, or how the light is being converted into that, it is just like you can see the diagram which is mentioned below. So unpolarized light is basically falling onto the surface of any material which is non-metallic. You have to keep in mind, like, we are taking those materials which are non-metallic, because metal, they tend to reflect the light in all directions, in multiple or random directions. That's why we cannot achieve polarization to its maximum. That's why non-metal surfaces, like a surface of asphalt road, snow fields, basically, like in Arctic regions, or you have seen, like, whenever you see or whenever you saw onto the to the surface of a snow, you feel like the light is too bright. Why that brightness is achieved, why that glare is like coming towards your eyes, is because of polarization, because the light which is coming towards your eyes, or the light which is being reflected, is a polarized light. Same case goes with water surfaces or any other non-metallic surfaces. So unpolarized light is being incident onto the surface, and after reflecting, it is basically going to get polarized in parallel to the plane of the surface. Like, if the surface has a horizontal plane, it is going to be get reflected, the polarized reflected light is going to be horizontally polarized. But if the surface is vertical, for example, if I draw a surface which is like this, it is a vertical surface, and the light is coming from this end, which is unpolarized, and striking the surface here and making a reflective angle at this point. Okay, so we can see, like, unpolarized light going in this form. So the other thing which we are receiving on the other end is going to be vertically polarized light on the other end. So what does this mean? Whenever light which is unpolarized is going to fall onto a surface, it is going to get polarized parallel to the plane of surface. So you can see this polarization is basically parallel happening to this plane of surface. Like you can see, or you can examine on pools as well. Like whenever you go for swimming, people used to wear glasses. So can anybody tell me, like, why we are going to use glasses whenever somebody is going on a beach or on a pool? Exactly. The glasses have been used because to reduce a glare. You can see like whenever the water on the pool is like waving, or we have having waves on the pool water, you can see a bright glare or a bright reflection of sun is seen on that surface. Why? Because of this polarization. Because unpolarized light, which is coming from sun, is getting polarized parallel to the plane of swimming pool. That's why you feel a glare. And to reduce that glare, we are using polarized glasses to reduce the amount of reflection, to make our visibility much better. To get a better visibility, we use glasses or sometimes swimming goggles as well. So these are some examples in which the light is being reflected, or the polarization is happening by reflection. Now, coming towards the second method, which says refraction. Polarization by refraction. How the polarization is happening by refraction? Let me give you an example and draw something for you as well. Like we have seen and we have observed normal refraction processes as well in sciences and in physics, since we are studying our science, or since we are studying optics. What happens when a light is being incident onto a surface? Whenever the light is entering from one medium to another medium, what happens to light? Some of the light is reflected and partially of the light is going to be refracted, or you can say it is transmitted. So this is going to be our transmitted ray. Let me draw it with some other color. So this is a transmitted ray, which is bending towards a normal surface. Let me draw a normal surface for you as well. This is a normal, which is going this way. So now you can see this angle is known as incident angle. Okay, this is one. This angle is considered to be as theta2, which is a refracted angle. So transmitted angle or refracted angle, you can say. So this refracted angle is a bit less than your other angle, because in refractions, the ray tends to be bending towards normal. Whenever it is entering into a denser medium, it bends towards the normal surface, the normal line. So some part of the ray is going to be reflected. So in polarization by refraction, we are not concerned about this angle. So let us say, like in refraction, when it enters into a surface, like into a denser medium, particularly into a denser medium which is of a crystal, some crystal. There are some different types of crystallines which we are going to discuss, which has been taken under consideration here. So whenever light is being subjected or it is passed into a crystal, it is basically reflected into two rays. So two rays are going to be refracted. One ray is refracted or is transmitted in horizontal polarization method. The other one is being refracted vertically. So in polarization by refraction, you can see two images after refraction. Two rays are going to be transmitted, one horizontally, one along the side of the plane, the other one perpendicular to the plane surface. So this vertical polarization is basically parallel to the surface of this crystal. This horizontal polarization is basically vertical to the plane of the surface. So if someone wants to see both the images, they can see normally. Both the images are like seen on that thing. But if someone wants to see one image at a time, so what you have to do, you have to use a polarize basically. Either if you want to see an image which is vertically polarized, so you can use a vertical polarizer. So if you use a vertical polarizer, this wave can be seen. This ray which is refracted can be seen, which is wave one. Let us say it's wave one. If you want to see a wave number two, which is this one, so you can use a horizontal polarizer by using glasses which is horizontally polarized. So you can use and you can see this transmitted wave in polarization by reflection. This is a bit of a review of your polarization by reflection method. Here you can see the example as well. Like when two rays are refracted, they pass through the Iceland spar crystal. As I mentioned, like we are using a crystal to check the refraction method. So when the rays are being polarized by this crystal, you can see two rays which are being transmitted. One wave is being transmitted alongside the plane surface. The other one is being polarized vertical to the plane surface. So that is how the methods of polarization, different methods of polarization are basically taking place. Now moving towards our law. What is Malus Law? Discussing about Malus Law. But before going into deep discussion, let's take the statement of this Malus Law. Malus Law states that the intensity of plane polarized light that passes through an analyzer varies directly with the square of cosine. This is an important part, so we'll discuss this whole law by a question as well. So it states that intensity of plane polarized light passes through an analyzer, which is basically a polarizer as well. It varies directly to the square of its cosine, the angle, cosine angle between the polarizer and the transmission of the analyzer. Let me show you its equation, which says like the transmitted intensity of transmitted light, intensity of transmitted wave, which is IT, is directly proportional to the cosine theta between the I naught, which is the polarized light. So here you can see, now this is your polarizer. You can say this is our analyzer. And we have a polarizer here as well. Okay, when unpolarized light is coming directly towards the analyzer, this light as being this analyzer is a vertical polarizer. So this is vertical, so it is going to be polarized vertically. As we all know, like whenever the light is going to be vertically polarized, its intensity is going to be get half. Why? Because half of its wavelength, or you can say half of its energy, is going to be get deducted. In this case, your horizontal waves are going to be blocked. That's why its half intensity is blocked, and half of the intensity, which is vertical, is passed through this polarizer. So we say like its intensity is going to be I naught upon 2. So it is let pass through this polarizer. Then when the other polarizer is placed at an angle of theta with this transmitted wave, which is polarized wave, it makes an angle theta, which this angle is going to be directly proportional to the square of theta, basically square of cosine. So let's say, as we all know, like intensity is directly proportional to the amplitude of the polarized light, which is A naught. This A naught is making an angle. The amplitude of this wave is A naught. And this A naught is making an angle with the amplitude of the other wave, which is being transmitted here after transmission. So its amplitude becomes A naught cos of theta, because it is making an angle here. You can see the angle theta is being made over there. So we say like I naught is directly proportional to A naught cos theta. As we all know, like intensity is equals to the amplitude square. So we can take the square of this whole thing, which is A naught cos theta whole square. When we divide these both equations, it becomes I is equals to I naught A naught square over A naught square cos square theta. So you can see this equation becomes dividing by these things. So your equation here comes up to be as I is equals to I naught cos square theta. This is the equation which we are getting for our Malus law. Now check one question regarding Malus law, which says a beam of unpolarized light of intensity I naught. So we had an intensity I naught is passed through a polaroid A and then through an polaroid B, which is oriented so that the principal plane makes an angle of 45 degrees. So here you can see a light is being passed through a polaroid, which is I naught. After passing through, we had another polarizer, which is being making an angle of 45 degrees. So you can see here, you can make an angle of 45 degrees relative to that of A. To that polaroid, this is making an angle of 45 degrees. Prove that the intensity of the transmitted light is I naught upon 4. So we had to prove that intensity is equals to I naught 4. Let's take the statement of your Malus law, which is I naught is equals to I transmitted is equals to I naught cos square theta. As we all know, whenever the unpolarized light is going to pass by this polaroid, it becomes I naught upon 2. So we say like I naught upon 2 cos square theta being equal to 45 degrees. So we say like theta is equals to 45 degrees. So your cos 45 becomes IT is equals to I naught 2 cos square 1 over under root 2, which is the cos square theta value. So when we complete the square, it becomes I naught upon 2 into 1 over 2. So which gives a value of I naught. So which explains that intensity is going to be 1 upon 4th. Mean the total intensity of unpolarized light is going to be 1 by 4th whenever it is going to be transmitted by two polarizers, which are in which one polarizer is being placed at 45 degree. This is your Malus law. Hope you understand this whole question. Coming towards its applications, what are the applications of polarization? In polarization is basically used in different activities, in different applications. One of the major application is to reduce the glare in windshields while driving a car, which is being achieved by polarized sunglasses. We have seen like in this activity, in this application, there's a document on a dashboard, which is basically creating a reflection on the windscreen. So with the help of these polarized glasses, you can reduce, and in this picture, you can see while wearing a glasses, your image becomes, intensity is going to be get reduced, which we prove in Malus law, and reflection is removed. So this is an application of your polarization. The other application, which is very common, and someone may ask you, sometimes children ask us a very simple question: why the color of the sky is blue? So the blue color of the sky is because of polarization. That is a method of polarization in which we discuss like polarization by scattering, how the polarization is happening with the help of scattering. So in this process, whenever the light scatters, all the colors, depending upon their wavelength, scattered at different points, scattered at different angles. So because of the atmospheric layer, whenever the sun is on the top or in the middle, the difference or the distance between our atmosphere to the earth is very short. So the waves which are scattering is basically not that much. So first two colors, which are shorter wavelength, they scatter a bit, and because of that scattering, we receive a blue color in the midday. So that is one of the reasons why our sky is blue. And that scattering is known as Rayleigh scattering. That is a name given on the basis of the person who discovered it. So these are some applications which we have discussed so far. Now moving towards the summarizing activity. Again, we are going to discuss an activity, and I'm going to divide you guys in group of 3, and you have to discover an activity on the basis of material I'm going to give you. So the material for this activity which you require is polarizing filters, sunglasses, corn syrup, picket fences, and a transparent tape, and some sources of light and glass slides. You're going to be in group of 3 people. You have to do this activity. You have to create a piece of art using a transparent tape. So it is an integration of art with physics. So have you create your own art depending upon the same process of polarization, and then record your observations and come up tomorrow with your modified answers. So you can display your art, and then we will discuss in the whole class. This is the end of the topic. We are going to discuss some of the points, summarizing all the topic from the beginning till the end. So in the beginning, we start off with a basic activity, which basically gives you an observation, how the whole process, how the today's topic is going to be. So you give your observation, and depending upon those observations, we continue our topic. From polarization, its methods. What is polarization? Is basically a process of transforming unpolarized light into polarized light. And then we discuss its different various methods, like polarization by reflection, polarization by refraction. These are some of the processes. Then in the end, we discuss polarization by scattering as well. So these are some of the processes or methods in which polarization can be achieved. Then in the middle, I show you with the help of diagram and illustrations, like how the incident ray is falling onto the surface and then it is being polarized. Then we discuss Malus Law, which states like the intensity of polarized plane when it passes through any polarizer is going to be directly proportional to the square of cosine of the angle, which is it making with the plane of the polarizer and the analyzer as well. This is your Malus Law. Then on the basis of Malus Law, we discuss one question and we prove one of the intensity, like whenever it passes through two polarizers, so its intensity is going to be 1/4. So this is today's answer. Hope you understand it properly. Thank you for listening to me.